Hello, and thank you for watching this August 8th weather update, brought to you by Agrible, the makers of Morning Farm Report. My name is Eric Snodgrass, and I'm a senior atmospheric scientist and co-founder of Agrible. Well, corn and soybean prices have been falling since mid-June, and most of the summer has been hot and wet. Crop conditions reports from the USDA have come in with a large percentage of the crop looking very healthy, like this picture taken by one of Agrible's drones in Douglas County, Illinois. All eyes will be on the USDA report that comes out later this week. But before we dig into a macro-scale analysis of the conditions of the crop, let's take a look at some of the exciting weather we had this past week. This last week, I was invited to present at the Farm Credit Services of America Young and Beginner Conference in Omaha, Nebraska. Now, just as I finished talking about how to best manage weather risk and how to detect several types of severe weather that could potentially do damage to your crop, like a tornado, well, we all walked outside of the hotel to see this waterspout forming southeast of the city. This video was captured by a passenger in an airplane and clearly shows the waterspout, but many were asking if it was a real tornado. Well, the answer to that question is yes. It is a real tornado because it fits the definition of a rapidly rotating column of air that is attached to both the base of a storm and the ground. However, waterspouts and landspouts are typically very weak and formed by entirely different mechanisms than the more powerful and more destructive tornadoes that form inside of supercell thunderstorms. Now, unlike the supercell tornado, which forms as the result of small-scale storm dynamics within the supercell that are primarily the result of strong vertical wind shear, the waterspout and landspout form due to large-scale horizontal wind shear. Wind shear is simply a change in wind speed and direction over some distance. Now, this radar animation from last Thursday evening shows why the storms that formed over Omaha experienced such strong horizontal wind shear. As you watch this animation, the fine lines of higher radar reflectivity that are caused by small boundaries between air masses that are moving across Omaha, well, one of these is actually just a cold front, while several of the others are outflow boundaries from thunderstorms, like we discussed in last week's video. Now, these boundaries are hard to detect to the untrained eye, but to a meteorologist, these lines represent areas where the air near the surface is moving quickly, and when these boundaries collide, strong wind shear is present. Here's what I mean. Take this plot of land. Let's say this was near Omaha. On Thursday, there was a boundary pushing in from the north, while another boundary was advancing from the south. Now, eventually, these two boundaries collide, and when they do, the air is forced to rise. If the atmosphere is warm and has a lot of moisture in it and is unstable, a thunderstorm will form on the rising air. Now, what causes the rotation beneath the storm to form the waterspout? Well, when these two boundaries collide, the airflow can occasionally spin up into these very small circulations we call eddies. From the side, we can see that the circulation then extends upward as the updraft of the storm pulls the air upward. The eddy is stretched as it is pulled, forcing the rotation to tighten and spin faster. If this happens over land, it's called a landspout. If it happens over water, it's called a waterspout. This is exactly what happened in Omaha, and here's a close-up view of the base of the waterspout. Now, they rarely do much damage, and wind speeds are typically much less than 100 miles per hour, but they are impressive nonetheless. So, getting back to the weather for the rest of the Corn Belt, the first week of August was dry for parts of Illinois and Indiana, but soil moisture is high enough that even with the brief shot of heat we saw last week, it likely had very little impact on crop health. This has been the story for this summer. Short durations of time where we had some dangerous heat, followed by a cool down. So the next round of heat arrives on Tuesday, starting first in the plains and the moving east. We are expecting triple-digit heat again in the western Corn Belt, but cooler air will arrive by the end of this week. This animation shows the 90-plus degree heat that's building from Monday through Thursday of this week. By Friday into Saturday, though, another shot of cooler air moves through, and most of the Corn Belt returns to more seasonable temperatures, which are typically in the low to mid-80s for this time of year. Now, there has been quite a lot of movement in the model forecast for precipitation this week, but here's the forecast as of Sunday evening for Monday through Thursday of this week. The start of the week looks dry for most of the Corn Belt, while the Gulf Coast near Florida is hammered with tropical thunderstorms. NOAA is predicting over 10 inches of rain, and maybe as much as 15 inches could fall along the west coast and panhandle of Florida. This moisture may also help the drought-stricken areas in Ohio later on this week, as storms are forecast to move through there. Now, looking much longer term, the flow of the jet stream over the next couple of weeks is showing no signs of blocking, which means that any heat that does build will be followed by a cool down. So, as we wrap up this video, let's discuss corn yields for the United States. The USDA will be releasing their next report later this week, and ahead of that report, we want to offer our analysis of yields. This summer's weather is unlike most years in that it was both hot and wet. May was problematic for some due to frequent rain, but June was very warm and dry for several large regions of the Corn Belt, especially southern Iowa, northern Missouri, and western and southern Illinois. Michigan was dry and hot and missed out on the beneficial rains in late June and early July. Ohio and northeast Indiana have had drought, and the western Corn Belt has been subjected to repeated days over 100 degrees Fahrenheit. Meanwhile, though, the northern half of Illinois, southern Wisconsin, most of Iowa, large sections of Indiana, and southern Minnesota have been reporting fantastic crops. Reports have come out suggesting that this crop could reach 175 bushels per acre, and some have been saying this will be the highest yielding crop ever. Now, Agrible's 13,000 field morning farm index, combined with our statistical modeling system, isn't nearly this high, and our projections are well below the 175 bushel per acre yields that others are proclaiming. 2014 was the best crop ever in the United States, yielding 171 bushels per acre. While we are forecasting a top 2 or 3 year in terms of yield, we are not expecting corn yields to beat those of 2014. Well, as always, we at Agrible will bring the latest and best weather forecast information through our morning farm report so that you can efficiently plan your operations. We thank you for your attention and hope you look forward to our next weather video update. Thank you.